let's say, two main categories based on the access. So the permissionless one here, so the public blockchain like Ethereum, Bitcoin, Avalanche, and so on. So everyone can see the history, everyone can join that blockchain, anyone can validate the blocks eventually. And yeah, so completely public. Then we have the permissioned one. So here we are applying some kind of authorization. It could be fully private and controlled just by one entity, or it can be controlled by a consortium of entities. So maybe like a group of companies that they want to be more private and not let everyone join. So lastly, there is like this hybrid solution that could be a bit public, a bit private, based on the permission that you are giving. So you can say maybe like everyone instead can see and join my blockchain, but just a few of them can eventually, I don't know, deploy smart contract or perform some specific action on some decentralized application, whatever. You can put like some of this permissioning. And the next one is blockchain is anonymous. Like the anonymous thing is really strong for many people that think that is one of the pillar, but it is like a bit misleading, because they are like pseudonyms, like you are using addresses. So if nobody has like the link between the this address that maybe is your address and your persona, of course you are anonymous. But if someone can entire history of all your transactions that you did. So how you can see it, how you can see like all these things thanks to blockchain explorers. So you can see, and yeah, so it is in a pseudonym way anonymous, but be careful of like sharing your addresses, because then like you can share it, like if you need someone that send you money, of course you have to share your address, but when like someone knows that that address is linked to you, they can go back and see all the history of all your transaction of whatever you did before. So the next one is all blockchain are decentralized. Not true, because like decentralization exists on a spectrum. Some blockchain have validators just concentrated, I don't know, in few areas, or they might be controlled by a small group of entities. So they are not really decentralized that way. But that could be like based on the jurisdiction, or like how they want to have their blockchain. But yeah, you need to understand that not all blockchain are fully decentralized. There is this spectrum of decentralization. Blockchain is always immutable. Immutability is one of the key pillar, definitely, but is also not absolute. So some blockchain allows to have upgrade, and like some, like the members, like the validators of that chain, if they have the majority, let's say, they can say, let's roll back and cancel some of the history, like cancel these blocks after this one. We will cancel this and we will rewrite the history, let's say. Why that might happen? Let's say that here it happened one huge hack, and here like the hackers moved billions of dollars in their wallet, and then they vanish. So they said, okay, that was a huge hack. We can't let that. We cancel those blocks and we start again from here. We stop the network, we fix the bug that caused that, and then we can continue. In theory, that's potentially good, but like for public blockchain, where there is like this decentralized trust between all the parties, is definitely not good, because you don't have the guarantees that in the future for their for something that goes in their help, they can decide to roll back what is not convenient for them. So in the public blockchain, like the rollbacks are almost never happen, or they will almost never do that. Otherwise, they will lose the trust of all the people that are doing it. In the private one, you need to be more careful because they have more power. They have the control of the network, and so yeah, that might happen. But you have to keep it in mind that it can change this immutability. One important thing also is like about the um, the learning of Web3. So in fact, for some people might be discouraged because there are new things. There are maybe like developers in Web2, and they don't know how to have this transition to Web3. So there are different ways, and Avalanche is providing many great hub where there is documentation, academic courses, some tutorials, some things to learn. So definitely, if you are super new to Web3, you just start learning some concept, check it out. Avalanche Cascade is like the introduction hub where you can like go to learn. There are some flashcards to learn some concept, or maybe like you already have some experience in other blockchain, and but you don't know much about Avalanche. So what you can do is like, okay, let's go to ecosystem map. You see some protocol, maybe like DeFi protocol. You have some money. Let's think USDC, some stable coin, and you want to lend to a protocol to earn some interest, but you don't know which are the protocol that are built on Avalanche. So here you can find everything, and for developers, some small tutorial and stuff like that, or just learning some concept, some technical stuff. But here in the Builder Hub, here you can find a more complete way to be a developer and a persona on Avalanche. So definitely check it out at the Academy. There are some courses such as Introduction to Blockchain, something that I'm doing, Introduction to Avalanche, and some that are specific to protocols that are built on Avalanche, and other stuff also, like the entrepreneurial one that if you're following that, but Doro will talk more about that later. And yeah, so definitely check it out. It's now way easier to start it. Don't be scared of some technical stuff or what you didn't learn before, because it's way easier and there are way more resources, and you will have also the support of all the Avalanche Team 1 member or like the Avalabs members. And if you have like any kind of project, whatever, feel free like to send some grant submission. If you are willing to learn, if you're willing to create on that, on Avalanche, I mean, there are many opportunities to get funded and get so much money and interested by the communities. So yeah, let's go back like to the myth. Also, like blockchain is free to use. Actually, not true, because the users need to pay some fees. They are called gas. So the public blockchain, they need to compensate those who maintain the network, right? So these validator nodes, the nodes that we talked before. And so people to send the transaction need to pay some money to send the transaction. And actually, these resources are limited. I really like the analogy of seeing the blockchain as an highway. So this could be like the road, and these red dots are like the cars that are passing through. And we will talk more later. But of course, like an highway, the road capacity is limited, the throughput is limited. So based on the condition, you have this toll market based on supply and demand. So if it is congested, toll goes up. If it's not congested, toll goes down, so you can pay less. Only like in the private blockchain, where you have full control of the native token and so on, or like in the test network, you don't have to pay. Blockchain is unhackable, definitely not. Like any system in the world, blockchain, of course, are designed to be secure, but no system in the world is 100% hack proof. So yeah, exploiting can happen at a various level. Could be smart contract logic. It could be user endpoint. It could be consensus mechanism. It could be bridges, like the one you see here. And probably it was like the worst one, because it was there were billions and billions lost every year in bridge hack. And because they are working, of course, not at a protocol level but at application level. The bridges are this platform, third-party platform, where that you use for like exchanging some token from a blockchain to another. So you have some token onto Ethereum, for example. You want to bridge to Avalanche, you need to use those. And yeah, so different things might happen. Blockchain is one size fits all. Definitely not. It was like more that in the past, but now we are going through more specialization. So different projects might have a different requirement. So yeah, let's think about your project. Could be like a gaming a game that you want to deploy on your blockchain, and your friend want to deploy like something related to decentralized finance, so DeFi, and a protocol for lending, borrowing money, or prediction market, whatever you want to think. Of course, there are really different projects, right? So you probably needed to have a different structure of your blockchain based on how you would perform the transaction, how they would be structured, and so on. So of course, uh, choosing the right blockchain or creating your specific blockchain depend on the use case. And yeah, I hope like this myth at least clear some misconception that might be around. And yeah, now we can continue with like some core concept of blockchain. So distributed consensus, that is the process of achieving agreement between these trusting nodes on the final state of data. And there are different algorithms. For example, Avalanche use Snowman, other use different protocols, algorithm. So they are different. But what you need to understand is the fact that there are some transaction that comes in from here, and those are like the nodes of the network. So they are trying to understand and having an agreement between the state of those transactions. When they reach it, they add the valid transaction inside the block with the other transaction, and then they add the block to the chain of blocks. And yeah, this is really important because if you already interacted, you probably know that if you want to interact with a blockchain, you need some kind of interface. So they are the wallets. And if you don't know, like you will need to download one wallet, and then those information will be really useful for you. So you like the wallet, what is that? Like is a database to store your private keys and track the transactions. And the wallet can be a hot wallet or cold wallet. So the hot wallet are the one that you install in the browser. MetaMask or Core Wallet, that is the one for Avalanche. And the Ledger, so the cold wallet, for example, Ledger is like a kind of a pen drive where, yeah, so it is like physical. And yeah, from the wallet, you get, when you install it, you get your seed phrase that it must be kept secret because that is the root of your entire wallet. So you have these 12 or 24 words. And by keeping those words, you can recreate the entire wallet on another device, for example, and you can generate multiple private keys from that wallet, from that seed phrase. So the private keys is generated, and it is alphanumeric string. You must keep it secret, otherwise the people can spend your money because they have the private key of accessing your fund. And after that, you have the public key that is generated, derived, let's say, from the private key that can be shared. And then the address that you can see are like the last 20 bytes hash that is derived from the public key. So let me go back here. Like this is the address. So that is the address that is derived from the public key. So public key and address can be shared without any problem. Just remember that if you're sharing your address, of course, people can link with your persona. So if I'm saying I'm Federico, I have this address, everyone can view whatever I'm doing with my wallet, with my fund, or who is sending like money to me or who I'm sending the money to. So let me get here. And yeah, so this is the address. And here I put like some example to be easier. Yeah, this is like how a block is. So there's like the header with the previous block hash that created this chain of blocks. Some information such as the timestamp, the nonce that is created for the Bitcoin mining, and the Merkle tree that is a data structure that contains some information on the transaction. And then we have the list of transactions that they get added thanks to the consensus mechanism. Yeah, let me open those link. So here you can see, let me just grab over there. Here there is like the kind of demo of what I showed before. So let's think like this is the blockchain. So we might have like this chain that is 5 block long. And what I mean before with immutability, or like anyone can see if something is getting changed. Let's think like here there are some transaction and so on. And after each block, there is an hash that represents the content of that block, right? So let's think that here there are some information like I sent $10 to Alice, I sent $10 to Bob, whatever. Instead, I'm trying to hack in that blockchain and trying to change here. Instead of saying I sent $10, I would say like I sent $10,000. So, or like I received $10,000, whatever. So I'm trying to change some value, whatever. If I'm changing anything, as you can see, you are changing the hash because the mathematical function hash take all the input and provide a fixed size output. And yeah, so that break this chain, because as you can see here, like I have this hash of this first block, and the second block has, of course, the previous hash here. So if I'm changing something here, then this will no longer linked. And yeah, what was like also the immutability part that was also mentioned is that if something bad happen and they want to roll back and so on, because it might be like a private blockchain, whatever, they can have the majority of the power or control of the network, and they can again recreate with the changes the chains from here and so on. So they are recreated. This is the new hash, and we are recreating the new blocks and so on. So yeah, here is just one thing that I want to share. And here there is like a more a visual representation. And I use like before the analogy of you can see the blockchain as an highway. And here there are like Bitcoin, Ethereum, can probably change also the blockchains. But yeah, here you can see like there is some congestion here on Ethereum. Yeah, you see, that's extremely good for us to see this. And you will see in a moment why I mean that. So
Yung, di ba na may parang hanggan din? Oo. Parang napatid. Yan! Kanina pa ako! Maghapon na ako!
Yeah, and so like I say, you can see like an highway. So the cars, the buses, whatever, could be like the blocks that goes through. And as you can see, there are like these that are the transaction that are inserted into the blocks. When they are full, when after some time they are sending by. Of course, since it's based on this toll mechanism that I explained before, you can see like here there are like some kind of priority, okay? Because if you're willing to spend more, you have more priority to go through and be the first in line. If you're willing to spend less, then you have to wait. So that's what causes this congestion, for example, on Ethereum. And yeah, so definitely those are interesting, at least to have some visual representation. Let me go back here. Yeah. So one important topic is the blockchain trilemma that was stated by Vitalik, the Ethereum founder. And he stated like that it is impossible to address all the properties of the blockchain. So decentralization, security, and scalability. But you have to take some trade-off between these three. So you have to pick, for example, one side and lack on the other one. So, for example, here security decentralization, for example, Bitcoin, or like this one or this one. But you will be lack on one of those. And yeah, then the smart contract. I don't know if you ever wrote one, if you know what they are. They were like kind of defined by Nick Szabo, and you can see like a secure and stoppable computer program that represent some agreement that will be automatically executable and enforceable. So to better understand the difference with normal contract that you might already sign it, I don't know, like your mobile SIM for your phone, if you rented an apartment or whatever. So those are written in your natural language, your native language, right? They are interpreted by the person, by humans. They're executed manually. If there is some problem, they are enforced through legal system, but they can be really ambiguous. Like if you take two lawyers on the same country, eventually, uh, they might disagree on the same piece of paper with the things written on. So what is different with a smart contract is that they are written in code. Solidity is the most common one, and those are interpreted by computer, and they are self-executing based on the predefined conditions that are written in code. And they are enforced, of course, through the blockchain technology and no more through like a system. And code is actually law, so that's why they are enforced through blockchain technology. But the important fact is that they have a deterministic outcome. So no matter where you are, like in the Philippines, you are in Italy, you are in the US, whenever you are, like the same input that I'm giving here or you are giving there or whatever, it will always reproduce the same output. So that's extremely important because it is deterministic. And yeah, there are different type of tokens, and those can represent some asset or value in the blockchain. There are two main categories. So the fungible one that are divisible. So they are non-unique and interchangeable. You can think about if you have one Bitcoin or one AVAX, whatever. You can also have like 0.0001 Bitcoin, right? That is divisible. You can change and get back the same amount. It's not a problem. Instead, the non-fungible token, all NFTs, they are non-divisible. So if you have one NFTs that represent some piece of art, you cannot say I have half of that, and they are unique and replaceable. And there's one small difference between coin and token. So the coin is the native digital currency of that blockchain. So for Bitcoin is BTC, for Ethereum is Ether, for Avalanche is AVAX. So instead, the token is the digital currency or asset that is built on top of the blockchain. You can think about USDC, like a stablecoin that is available and represents some asset. There are different type of tokens. Without going in depth, ERC20 for fungible token, ERC721 for non-fungible token, ERC1155 for like manage both fungible and non-fungible token. Okay, yeah, sorry like for the technical details, but I I know that they are important, but they could be really overwhelming with all those information. And yeah, you might be wondering like, what's the point? Like, what problem does it solve, blockchain? And yeah, different things. Ownership. we sorry, we mentioned before like you have the ownership of a digital or also physical asset that could be some kind of art, that could be some real estate, it could be music, whatever. Finance, you can lend or borrowing or exchange your asset by using one of these protocol or many more. And you are doing it in a transparent and super efficient way without intermediaries. Traceability, like for industry in food, they're extremely important. Digital identity, to provide like your identity without revealing unnecessary information. Gaming, like if you are a gamer, for example, you definitely know like if you played something, you oh sorry, you have like the like you enjoy it, of course, but you don't have any kind of ownership. You can think um, that you are farming something, but those are simply some pixel on your screen. Instead, here with Web3 games, you also earn some uh, rewards, some NFTs, some tokens, some way of getting some money. So let's think of the Grid, that is one of the main games in Avalanche, that is a first-person shooter. Maybe you get some skin, maybe you get some special weapon, maybe you get something. You like the game, you can even buy more from the marketplace. Then you get bored of the game, you can say, okay, goodbye, I'm changing the game, I want to play something else. You can sell and get some money. So that's amazing. That created like some economies within the game. Governance, so that's can base on like your participation and like how much tokens that you have. You can have more transparency and more participation based on the interest of the people. So all good. And we now know the theory, but and we know also like what are like the what problem that does it solve at the blockchain. But how do I actually use the blockchain? And we mentioned before, thanks to the wallet. So here, if you want, you can download the core wallet, or there are other wallet as well. But this is like your interface to blockchain. So you can manage across multiple blockchain. You can have access to your private keys. You have your balance. You have the possibility to send a transaction, of course. So this is your first interaction with Web3, with blockchain. And now I wanna like addressing some more information, like how it actually evolved through the years. So everything started with Bitcoin in 2008, 2009. So one blockchain, one asset, BTC, right? And then Vitalik in 2015 created Ethereum. And it actually understand that one asset was not enough. Not only the native token, so Ether, but also more asset that can represent some value, some asset. So I don't know, USDT, NFTs of various purpose, whatever. So that enable way more possibilities. But now we are transitioning with the ecosystem like Avalanche. So of course, multiple assets are extremely important, keeping that, but also one blockchain, like we saw before, could be really challenging because it might get congested. It might not be specialized enough for what we are trying to achieve. So we are adding also multiple blockchain and not only one. So for those, I don't know, like if you search something about Avalanche, if you're an expert, if you are like the first time that you heard about, and but like Avalanche is an open source platform, so it's definitely open source. You can build a decentralized application in super scalable and interoperable way, and we are creating like this ecosystem of chain. So we have this layer 0 architecture that allows the developers to create a customized layer 1 blockchain that can actually tailor your specific need. And by the way, Avalanche is also the currently the fastest smart contract platform in terms of finality time. So what is the key point of Avalanche is we have a multi-chain architecture. So no longer a single blockchain and a validator set like we see before, or like if you are thinking on Ethereum, but we have an heterogeneous network of blockchain and validator set. Okay, I know that is probably difficult to visualize it. I need to move that slide. This could be like a visualization of what of how does it look like Avalanche network. So what we are seeing here, like the primary network of Avalanche with the validators node, okay, and those are other blockchain with their validator node. This is the FIFA for football, Beam for gaming, and other things. So all these blue dots are the layer 1, so the blockchain inside the ecosystem of Avalanche. So this is the visualization, and if you want, you can go check on Snowpiercer to have like a more updated one. So at least now we have the visual representation in your mind. And let me go back here. Yeah. And now let's talk why, like, what is this Avalanche layer 1 and why you should start creating one. For three main reasons: scalability, independence, and customizability. So for what's the scalability? You don't have to compete for block space with other app because you can have your specific and dedicated resources. So it is like an horizontal scaling approach, but we will talk more in depth later. Independence, so you can control your transaction fees, your tokenomics, and the governance. And customizability, so you can design your chain to meet the exact need of your project. It could be gaming, enterprise, DeFi, whatever. Okay, let's talk about the scalability. So I mentioned before, and we will continue to use this analogy of an highway. So here you can see like the highway, like the blockchain can be seen as an highway, right? So transactions are like this car that are driving along the road, and every time we are sending a transaction, so we are sending a transaction, it's like sending a car on a journey from the starting point to the destination point. So what might happen is like the road, the highway can get congested, like you can see here, like we saw before with Ethereum, for example. So how we measure like the performance of blockchain? We have two ways, so the throughput and time to finality. So the throughput is actually the number of cars that can be fit, like that can pass per second, let's say. So how many cars they can pass per second. And in performance metrics with like the blockchain names, you can find as transaction per second or mega gas per second, because the fees are paid in gas. This is called gas. And then there is time to finality. So the time to finality is actually um, it's not like about how many cards they can fit in, but it's how fast they can go from the starting point to the end point, and be sure they actually arrived. Um, Extremely important point here. So what is happening on Avalanche? Instead of having one huge blockchain that might get congested, you are specializing in different highways. So what we want to achieve, high throughput, so a good number of lanes, let's say, and super short and direct path. What we don't want to achieve is like a long path that also is super low on throughput. Here, like you can see the metrics for comparison to put in perspective, Avalanche layer 1 with Ethereum or Bitcoin. And here you see like there are visual representation in highway terminology. And yeah, so what's important about the scalability is the fact that we can add more of this layer 1 specialized. And by adding those, you are combining the throughput of all those, okay? But you are still keeping the short time to finality. So Avalanche is the fastest one in time to finality. And you just need to add more layer ones that are specialized for one specific purpose, and you are good to go. You can have almost a limited throughput. And also one important thing that we will not discuss, but is extremely important to understand about Avalanche, it is that they allow native interoperability. What does it mean? So this is the primary network of Avalanche, the one that we saw before, and those are the other layer ones, the blue dot that we saw before. And yeah, so maybe you are like here in your layer 1, here there is another layer 1 and so on. Maybe you want to send some token, you want to have some interaction with other blockchain. And thanks to two big protocol of Avalanche, called interchain messaging and interchain token transfer, you can actually send this token or messaging to other blockchain inside the ecosystem without the use of bridges that we saw before that might get hacked quite, not say quite easily, but might get hacked. Um, so yeah, that's extremely important to understand. One important thing is like you might have heard about layer 2 solution. So those are also like addressing the scaling problem, but they're doing it in a completely different way. So they're doing a vertical scaling approaches, and so they are not providing some independence from the bottom layer. So they are really linked, and only application level changes are possible, and they are not customizable. So definitely different from what Avalanche allows. In fact, Avalanche allows to have independence. So you can control those, you can control traffic rules, this highway analogy. So we mentioned before, the throughput, so the number of cars that can pass per second, is limited, of course. So you have this toll system that is based on supply and demand. So if it is really congested, like we saw before with Ethereum, you have to pay more, right? Because there are not enough resources. Everyone try to have those. So if you want, you have to pay more to have more priority. Otherwise, you will wait here. If the network is not really congested, you simply pay less. So that's how it works. What is happening is that this is the Ethereum gas price chart, and as you can see, there are many, many spikes. Those are when the network, so Ethereum, get congested. And those can be really, really expensive. It could be like $1 or less than $1 when it's not congested, and here on those spikes could be hundreds of dollars. So definitely not suitable for small businesses. That doesn't provide some price stability, right? So that's could be really, really expensive, and like small businesses or like small decentralized application that try to emerge, if there is like huge period of I don't know, FOMO, NFT drops, airdrops, whatever. So a really high activity, then it will be super expensive to send transaction, and that would be not so good. What is instead happening on Avalanche is, let's imagine the same situation with Avalanche. So Avalanche primary network get congested, right? So the toll mechanism that we discuss will rise up the gas price for sending a transaction here. Okay, all good. But if you have your own blockchain, your layer one, you still don't care. Like you don't care because you have your native token, or like you can also use like some more stable token for paying the gas fees, and you don't suffer from the congestion on another blockchain. You don't care. That's extremely helpful to have some stability. Customizability. So yeah, we said before, no longer one size fits all. So you can design your blockchain that fits your need. So uh, you can create the exact same road for your traffic, and that can be really different from a layer one to another layer one. Um, with layer two solution, actually, it's not possible because you are relying on the lower, like on the parent chain, and the execution environment also can be changed because it supports a different one, and also like different programming languages. Maybe like your team is really specializing on Rust, so you can develop in Rust. Maybe you are super skilled in Solidity. Let's go with Solidity. So you can also change um, those things. You just keep like the Avalanche consensus mechanism, and this is more for enterprise use, but it has this permissioning for uh, for having like this uh, for solving like the compliance requirement. So what might happen is like I can actually add some permissioning on validators. Let's say I can impose some hardware restriction or location restriction and exclude some countries and say yes to the others, or um, or like some hardware that might need to be at least at certain level. That could be good, like for example, data privacy laws. Maybe some countries you need to exclude from those available, and also like for smart contract deployers and user. Let's think about when we talk a different type of blockchain. We also mentioned that we can have a hybrid solution, right? So maybe like I create a layer one and say everyone can interact, everyone can send their transaction, okay? All the user can send, everyone can also see the history and so on. But just me and 10 other addresses, people that I know, that are developers, whatever, they can actually deploy the smart contract. I can do that and give me more control over what is deployed and what the people are actually interacting with. So here is like the image from before, and I think now that you are seeing it again, maybe it makes much more sense, or at least I hope so. This is the primary network with their validator set. These are the layer ones with their validator set, and this is the entire ecosystem. So all this blue dot, this layer one, they can communicate with all the other blue dot, with all these network, of course, also with the primary network as well. And so that's how it looks like. And yeah, that's why I said it's a network of network. This is a network, this is a network, this is a network of networks. So definitely, if you're interested, and there are many possibilities, like I said before, type build.avax.network or use the link like I showed before. Um, There are many academic courses. There are many ways to start learning, to start building, to acquire some grant or having some help with your project by developing your project. Or it could be like it could be completely new. It could be a continuation of a previous project, whatever. Like Avalanche is really pushing hard on that thing. So if you're willing, if you're eager to learn, definitely check it out. Check it out. And yeah, Avalanche Cascade that I also mentioned before. Definitely the official hub for onboarding the people that are super new to Web3. So there are more introduction things where you can take a look. And yeah, thank you everyone for the attention. I know I covered really a lot today. So and also like say let's say short time is not so short, but if you have like any question, feel free like to type in the chat or like if you have after this meeting, feel free like to write to Sean or anyone from Team One, and you will get like some reply for sure. So yeah, hopeful. I really hope that would be useful at least to give you some insight about having a better understanding of blockchain technology and about the Avalanche, of course. So yeah, hopefully that would be something that you can you can take a look into it and continues progressing while learning. And if you want to add me like on LinkedIn or whatever, and yeah, thanks a lot for your time.
Thank you so much, Sir Federico. Now, if you guys have any question, please leave it in the chat box. And later, at the end of the discussion of the overall event, Sir Federico will answer your questions. So just drop it, guys. Now, let's move on to the next topic, which is about the academy campus program. Now, I'll share the video.
My name is Doro Unger-Lee. I lead university engagement for Avalanche, and I'm super excited to be here with you today to tell you a little bit about the opportunities we offer to students and university faculty and any educator and learner on the planet in the Avalanche ecosystem. So first, you're probably wondering, why does Avalanche really want to engage with students? Well, we really see you as the true innovators, not of tomorrow, but of today. And we really also cherish our relationships and partnerships with those lighthouses of knowledge and innovation, the faculty and the professors on your campus. And we know that you now, in this phase of your life, have the most innovative ideas. You're the most curious and you're eager to learn. So we are excited to be working with you and offer many fantastic opportunities for you in the Avalanche ecosystem. For now, please do join our program and scan the QR code to be part of it. That means you will be the first one in the know about any internship roles coming up, about bounties that you can tackle, and about our university events. It'll also mean that anything that is university related that we do, you'll be the first one to know. And I personally will reach out to you after you submit your form. And I want to learn about your interests and what you are fascinated by in Web3. So what do we actually offer? Well, we have 4 entry pathways, but I'm going to collate the third and the fourth one together in the interest of time. And our program rests on these 3 pillars: learn, connect, build, and innovate. Okay, I'm going to go through each of these learning offerings, connection offerings, and these really benefits for you to build and innovate in the Avalanche ecosystem now. So how can you learn with Avalanche? We offer multiple free certification and learning programs, no matter which background you're coming from. So first of all, I want to highlight the Avalanche Academy. For those of you who are interested in the technical quirks of Avalanche and want to become a certified Avalanche developer, great. Avalanche Academy is for you. This is where you learn hands-on what blockchain is all about, what Avalanche is all about, and how you can build great things on Avalanche. But please, for those of you who are not technical, please have a look and start the Avalanche Academy as well. There's lots of hands-on exercises that really walk you through step by step. So for those of you who always wanted to become a developer, but you sort of shied away from it, please take a look at the Avalanche Academy. It's a wonderful learning program for you to really make the most of your learning capabilities and your interests. I also want to highlight the OWL Explains platform run by our legal team. This is very much for those of you who are interested in policy and regulation, and you also want to approach a blockchain from a non-technical perspective. So please go ahead and check that out. Sign up for the newsletter or listen to the podcast where they interview academics, regulators, policymakers about what's going on in the world of blockchain policy. Super interesting. And then I also want to highlight our faculty development program. Again, we're not just working with students, and our Codebase Entrepreneur Academy. So again, why do we want to work with faculty? Well, faculty are the teachers in the room that you're listening to every day. And we want to make them confident in understanding Web3 technology, blockchain technology, and all its applications in a way that they can integrate it in their curriculum, and then they can make you benefit from opportunities that Web3 offers. So we were really keen to connect with faculty all over the world, no matter if they teach CS or art, history, or German, we don't care. We just want faculty who are really interested. We just ran our first faculty development program over the summer of 2025. It was a huge success. We had applicants from over 25 countries. We had many graduates from countries like Bhutan to the UK, from Indonesia to the US to India, Pakistan, Turkey, you name it. And it was a wonderful experience. So we're hoping to continue this program, and we're looking for you faculty to come and join us on this important journey. I also really want to highlight a wonderful new education initiative that we built, the Codebase Entrepreneur Academy. So for those of you who have that one great idea and you really want to turn it into a revenue generating venture in Web3, this is your program. Here is the program where you can learn all the entrepreneurial skills that you need to build your successful startup on Avalanche. We cover everything from IT security up to go-to-marketing strategy. We look at social media and community building, but also how to present the perfect pitch. So really, in these 11 modules, we are covering everything you need to know. And the teachers are the best people you can learn from. True experts from Avalabs, Avalanche Foundation, and the Avalanche ecosystem, who tell you in simple steps what you need to do to build a successful venture. And the good thing is you can get certified for free at each level, and you can showcase those certifications on your LinkedIn, on your socials, and it helps you really to present yourself as a well-educated and well-rounded founder to VCs, to funders, and so on. So please, please, please go check it out on build.avex.network. I also want to highlight connection opportunities, and you're already doing this. You're here at an event from Team One or from Avalanche or from our big, big ecosystem, and we're delighted that you made the choice today to join us today. And I always say innovation is a context point. We need people to come together, and friction is also where the innovation happens. So we do lots of events at universities all over the world through Team One, through our company. We also do host hackathons and events really everywhere in the world. We also do virtual events like our monthly Campus Builder X Spaces series, And we're also looking for students like yourself who we can really drive the movement forward and found Team One University clubs. So if you're a responsible student and you have what it takes to lead a group of students who are interested in Web3, excited about the potential that Avalanche can bring to the table, and you want to help educate your fellow students and also maybe your leaders and faculty on campus, this is an opportunity for you. So if you're interested in starting and leading your local Team One club on your campus, please reach out to me or your local Team One ambassador, and we'll be happy to help you with that. The last and sort of combined pillar of the university program is our Build and Innovate pillar. So again, build.avex.network is a website I mentioned earlier. Please bookmark it. This is your resource for everything you need to know about learning, connecting, and building on Avalanche. On this website, you will find information about our grant programs. You'll also find access to all of our learning programs, and you can also find our bounties there. So for those of you who are interested in learning and earning at the same time, please scan this QR code. We're always looking for dedicated student talent that's keen to create content, tackle the bounties, learn about the content as they're creating it, and make a buck. So this is really a wonderful opportunity to learn and earn while you're on this Web3 journey. As you know, we're also doing tons and tons of hackathons, virtual and in person, all over the world. And the excitement is really feelable for us. So our recent Hack to Build was, for example, focused on privacy. And you can not only win lots of money, you can also learn delightful skills and you can expand your network. Hackathons are really much more than a competition on who has the best ideas. Hackathons are opportunities for you as students and also for the faculty in the room to apply what they learn in the classroom, to build teams with others, to learn from people from different backgrounds. And please, I cannot emphasize this enough. You do not need to be technical to be part of a hackathon. You can pair up with anyone who's in the room, make new friends, get leadership skills, and really bring what you know and can do best to the table. You love design, you love project management, you're creative, you are very good at keeping the team on track. You don't need to know how to code. So please, even if you're not technical, come and join our hackathons, build a team with your friends or with brand new people online or in person. And you will not only build your quantitative skills, but also you will learn so much from all the workshops and educational programming that we offer throughout our hackathons. We also meet people all over the world, and I can't stress this enough. If you want to land a successful career in Web3 or you want to start your own project, you need to have a network of people who support you, who believe in you, and you can start building this network in an Avalanche hackathon near you. So that's it from me. Please, again, do join our Avalanche University program. It's absolutely essential. Let me hear from you, hear about your interests, who you are, where you're from. Please connect with me individually. I'm always happy to talk to anyone and everyone. I talk to students from all over the world every week. That's why I love my job. And for those of you who are interested in starting your own Team One club, speak to your local Team One lead or member, and they can help you with that or reach out to me directly. So that's it from me. Thank you very, very much for your help, and I look forward to hearing from you. Thank you.
Now that's Ma'am Doro, so hopefully you learned a lot about the campus program. Now I'll share another one. Now this is about a workshop, Avalanche workshop.
Hi guys, good day. So, welcome to Getting Started with Avalanche, expanding with solidity foundations and best practices. So yeah, first of all, I'm John Octaviano. I'm a mid-level software engineer with around almost years of working experience. So I have knowledge in software, DevOps, cloud, blockchain, data and AI, alongside security. So I know I'm also the regional tech lead for Team 1 Philippines. Okay. So, first of all, we'll talk about smart contracts. So, basically, smart contracts are just applications, right? Applications that runs inside the blockchain. So, basically, smart contracts, if we have some quite background about programming, basically, ano lang sila, basic application. Iba lang ang tawag, smart contracts. But, technically, under the hood, for developers' perspective, they are just applications. If you have knowledge in Java, they are similar to classes. In JavaScript, they are similar to classes as well. If you are using 6+ versions in JavaScript, what else? If you have knowledge in C#, or C++, similar siya sa concept ng class. So basically, meron pa rin concept ng object-oriented programming in a traditional programming sense, right? So smart contracts applications very similar. And one of the most popular programming languages to build smart contracts is Solidity. So some blockchains uses Rust programming language. So Rust is a programming language similar to C, which is one of the fastest programming languages out there. So Cairo, not so much, but yeah, Solidity and Rust is two of the most popular programming languages to build smart contracts or applications that run on a blockchain. And for this session, we will talk about Solidity. Okay, so ito yung basic syntax ng Solidity. So we have this thing called SPDX, license identifier. So basically, before we deep dive to the actual syntax, let's talk about yung pinaka-general structure niya. So just like what I said, similar siya sa typical programming class, like classes, right? And you have properties like colors in this example, and then functions. Okay, so basically parang lang siyang classes. And if you have background knowledge on those programming languages before, learning Solidity would be easier. Building on Avalanche as well. And yeah, what if not again give us the necessary tools to program? So we could use IDE like Visual Studio Code or Cursor or any other editors out there na may support kay Solidity, but in this case, in this session we'll use Remix IDE kasi mas madali dito and mas intended siya for beginners and mas madali siya gamitin as well kasi nandito na yung general tools na kailangan natin. Hindi natin kailangan mag-setup, hindi natin kailangan mag-install. All we need to do is just use this web-based IDE. So you could actually access this link. So I created a file here under contact folder, college voting. That's all is yung actual file extension in Solidity, right? And then to cover natin ngayon is, so basically we will cover this basics like structs and mappings, right? We're supposed to talk about ano ba yung modifiers, ano ba sila? Modifiers. We'll also talk about enums, what are enums? We'll talk about events as well. We'll also talk about different function access, or basically access modifiers, right? And we also talk about contract bases and logic flow. But yeah, the build natin now is basically the basic college election system. I-build natin. So yung mga users pwede sila register, pwede yung mag-vote for candidates at the same time. Alam yung system kung sino yung contract mismo kung sino yung winner. Great. So first of all, ano yung pwede natin gawin? So this, what we could do is, we could write so meron siyang AI, but yeah, we will write everything from scratch. So first of all, we'll define an enum here called base. So base is basically yung state ng application, kung ano yung state natin ngayon. Example, create maybe registration here, voting same time, and then so basically yung registration base kung saan mag-register yung mga voters, pati yung candidates, right? And then, so basically enum, ano ba si enum? In the original programming sense, enum is basically enum is basically it allows us to define a set of named constants. So basically we have these constants, right? And then in constants na yan, these values na meron silang kapag magbabago. So itong base enum, meron siya kasi tapat na siya 3 values: registration, voting, and end. And those are constants, we just need na sila magbabago. And purpose nila is basically to they help us control yung actions that are allowed specific pages. So basically, yung purpose ng base, right? Yung purpose ng base display lang. And then you could create another, or no, basically your current page, right? So current public, current page. In purpose to is tinatrack niya yung current page to application, right? So yeah, kinikip track niya yan. Then next is what we could do is so yeah, yung purpose, it's basically for constants values na never napapago. So well, just like in other programming languages. Next is we have create a new address here. So public admin. So basically kung sino yung admin. So tinatawag ito yung kung sino yung admin. Ito naman yung current page ng application. So as you can see here, we use the word public. So basically public is open for everyone, right? Same with admin. So pwede siya makuha. Then we will start creating here what they call a struct is candidate. So struct is basically a purpose of struct is to group, right? Group related data together. Okay. Basically to group those related information. Just like for example sa candidate member, this is a typical candidate. Meron siyang name, right? And then meron din siyang urine. 6, which is a number, right? Or meron ko na may photo niya, right? So basically yung purpose ni is group with create a class together. Okay. So yun. So basically so it represents the different candidates. And then meron tayo dito for voters, right? Voter. So as you can see, yung meta ng string for strings and unit 56 for numbers naman. It is kumita ng sa voter, you could just pull. It's basically pull registered. So kung natak niya yung kung nakapag-register na ba si user hindi pa. Same with voted. Kung nakaboto na si user hindi pa. And next is maybe unit 56 or ano naman. So I have candidate here and I have voter. I think it's a good idea para matrack natin yung index, right? So kung ano yung index ng binoto niya kasi isang beses nang pwede bumato sa user. So just like what the AI recommended us, but in this case I think it's used both index na. So it tracks kung ano yung sinong candidate yung binoto niya, right? Both index. What else? So yeah, so meron tayong voter, meron tayong candidate. So I think it's a good idea to start writing some mappings here. With what we put here. So ano ba yung mappings? So mapping is basically yung ano ba term? So mapping yung syntax niya sa voters. Okay. So basically mapping. Ang purpose is mapping is para siyang dictionary in a typical programming language where purpose niya is wait lang. So let's define a new candidate here called public candidates. So basically tinatak na to yung voters, right, sa application. So itong address siya yung so basically to store those voters and to access them, gamit yung access is yung data type is basically an address, right? So ito yung data type address. So basically to get a specific voter, we will get them by passing an address. Basically yung address nila. We just need to nakita natin yung address. Basically siya yung unique identifier ng isang user, right? And when we pass the particular address, the designated voter yung ma-return sa atin. Okay, so basically ganun sa mapping. So we create a mapping here for voters, and to access a particular voter, ipapasa out natin yung address ng voter na gusto natin muna, right? So, and I also created here candidates or candidate array for candidates, right? So basically, itong array na to is actually siya dynamic array. So, hindi siya fixed size. So, nag-i-increase yung size niya. Okay. So, again, so yung purpose to is basically stores information in a basic sense, right? So, basically yung key type and yung return type. Kung hindi return, right? And yung candidates naman is basically an array. So, stores information. Okay. Okay, so what's next? So we have candidates here. Meron tayong for voters. Pwede natin gawin. Because we could start to talk about ano ba sila event, right? Whether event or candidate registered. So event is just basically like announcements on the blockchain. Now, so malaga yung events because they have a different what I call this, different purposes. Kasi itong mga smart contracts, pwede natin sila ma-integrate in a websites, right? We could build applications on top of this smart contracts. Ngayon, so basically, parang itong smart contract is makapag-interact siya dun sa front end natin. It's basically, if you use React or Next.js, like all those frameworks to build applications, to basically integrate this smart contract on those applications. So they allow, okay, so in a basic sense, they allow front-end applications, right, or external applications, no? So like a website, web apps, or web apps na to react to those contract activity. So itong mga events na to, binibigyan natin ng capability na maging interact, na makipag-interact ito sa applications na yun na possible natin gawin in the near future, right? So ano yung pwede natin gawin? Event. So ito yung syntax niya. So later event. So smart enough yung AI, it actually use that and candidate registered. But in this case, we could just basically use name na for now, just for sake of simplicity. We also type voter registered. Right? So basically yung ginagawa nito is, or kapag si user is nakapag-vote siya, or nakapag-register siya, no? And then you could also add podcast here that says address, voter maybe, and then string candidate name. So itong event na to is for kapag si user is nakaboto na siya. So this one is for kapag nakapag-register si candidate. Ito naman is kapag nakapag-register si voter, and kapag nakaboto na si voter. So basically, events, they are typically useful for making the smart contract have the ability to interact with the external applications. Kasi possible kasi yun in which what we call or dApps, right? dApps. Decentralized application. So applications. So basically, dApps are just your are just applications that with smart contracts, right? So itong events, nagiging possible yung dApps because we have these events as well. Kasi naalo natin smart contract na may pag-interact in those external applications, and or which is what we call dApps, right? So that's the most basic stuff about dApps. Next is event. That's each election ended, right? It's basically a string winner. Then you take votes natin yan mamaya. So ito yung mga events ng application. So kapag nakapag-register candidate, same with voter, nakaboto sa voter, at the same time kapag natapos yung election. So di natin kasama yung ibang events. Let's focus on this. I think yung mga mandatory events for this application. So we have talk about enum. So again, enum is basically constants, which is mga values na dapat na magpabago. In this case, we create enums for basis ng application kung ano yung state niya. Next is gumawa din tayo ng basically variable. So this is a variable, by the way, a property. So address is basically yung data type. So address is something like this. Like this. So ito yung itsura ni address, typical address, which is ganyan, fetch data. Which is similar to basically similar to like this. So ito yung address. So hindi siya basta string, normal na string, kasi since we're in a Solidity programming language, these are considered address, something na different sa normal string, unlike in a normal programming language where since these are a collection of characters, so making string to right, typically. Pero since we are using a Solidity programming language, then this one right here, address, stores, or it is considered as address, data type. So gumawa din tayo ng validate structs alongside for voters, basically to group related together. So gumawa din tayo ng mapping to store information. So gumawa din tayo ng array for candidates as well. And then yung events, to track yung events na nagaganap sa application natin. It's basically to allow the smart contract to interact with external applications, right? Or what we call dApps. Okay, so ano pa kailangan natin next? So kailangan natin gumawa ng modifier, right? Modifier. So we add the admin. So let's type it out and message sender. So I will explain it. Explain it, right? So and then right. Just yeah. So ano yung modifiers? So ano ba yung modifiers? So modifiers are just basically a usable function used for what? Restrictions. Okay. So they are just basically functions pero ginagamit sila for restrictions. Why? So in this application, college voting, gumawa tayo ng modifier which is on the admin kasi we only want na isang tao lang yung kaya mag-control ng smart contract. Basically, siya yung hindi naman totally mag-control but siya yung may full authority. Siya yung may-ari. Kinda may-ari ng smart contract na to. And gumawa tayo ng restriction na on the admin for those selected functions later na dapat si admin lang yung may access. So that's modifiers. Basically, gumagawa. They are just usable functions for restrictions. Okay. And then we have this, kapag gagawa tayo ng modifier, typically we need to include require. So siya yung condition. So if yung message the sender, where this message is sender. So basically we have this thing called message. Siya yung global object. So global object siya na pwede natin ma-access. So global object siya, meaning it is available anywhere in a typical solidity. And then meron siyang property na sender. So basically, yung sender na yun is kung sino yung nag-execute later on nung transaction. We just try to makikita natin interaction when we start interacting with this smart contract. So basically, and then I have this underscore. So basically, to continue this application, right? So yeah, that's restriction or modifier. So we want a modifier for on the admin. So basically, we only want some parts of the application na may tayong si admin lang yung access, right? And gagawin tayo ng same modifier for what? or in place, right? So bakit kailangan sa in place? Well, we need to create this, right? So in place. Para yung current place pa natin. Current place is space, which is space. So purpose nito is to basically to basically ensure na yung isang function is allow lang siya depende sa state ng applications. For example, basically ensures that a particular function later na gagawin natin is only called only in the correct place. Bakit? Kasi since we have a current pace here, right? So kapag ang pace natin is nasa registration pa lang, hindi natin pwedeng i-allow yung mga users or yung other users na or kumuha ng mga functionalities na related kay voting tsaka kay ended pace. For example, since na registration pace ka pa lang, hindi ka pa pwede mag-start ng voting, right? No other voting pace na actions like mag-vote, diba? Same with ended. So kapag ended na yung pace natin, tapos na siya, hindi ka na pwedeng bumoto. Which is yung pagboto is part siya ng voting pace, right? And hindi ka na rin pwedeng mag-register kasi nga part siya ng registration pace, right? So gumawa tayo ng in-pace to call this in-pace modifier to track the current pace ng isang application at the same time kung i-allow ba natin yung isang function na mag-run na nakadepende sa pace. So again, if ang current pace natin is registration, hindi tayo pwedeng gumawa ng action na related to voting kasi nga nasa registration pa lang tayo, so nag-register ka pa lang ng voters, ng candidates, right? So kapag nasa voting phase ka na, hindi ka na pwedeng gumawa ng registration related actions like yun nga, creation ng voters at candidates. Same with ended, hindi ka na pwedeng mag-vote or mag-register ng mga candidates and voters pag nasa ended phase ka na kasi tapos na yung voting. So registration as well. Okay, so ginawa natin yung modifiers na yan for restriction in which it will increase the security of our smart contract, okay? Kasi meron tayong condition na pwedeng i-run muna, consider, in such that reusable to mga to, okay? So basically access. So basically to control access. To control access. No, not access. To control something. Okay. Something. Right. Nandito gumawa tayo ng constructor. Right, constructor. So admin. Center. And then so base. So ano yung sa constructor, right? What is constructor? So yeah, so meron akong wrong syntax here. So yeah, hindi na pala yung spelling. Dapat constructor. So ano si constructor naman? So basically si constructor, they're just your basically siya yung mag-run a function that will run only once when our contract is deployed. So basically, ito yung function na mag-run pag na-deploy sa smart contract. So for example, in this case, itong smart contract, for example, i-compile natin siya, right? So in this remix, you could actually click this Solidity compiler, right? Click compile for college voting, that's all. And then sa baba niya, we just deploy na transactions. You could actually click deploy. So kapag na-deploy sa smart contract, for example, it allows us to interact with this particular smart contract, right? And then yung function na mag-run kapag dineploy siya is ito, yung constructor. So basically, gumagawa tayo ng instance ng particular smart contract na to, right? And then ito, for example, yung parang smart contract na deployed. So example lang na deploy ito, for example, sa isang blockchain, right? For example, Avalanche, right? So ito yung parang tool chain or a simulation that remix gives us to basically interact with our smart contract, right? So ito yung purpose niya. So ayun. So yeah, since di pa tayo tapos, let's continue. Pwede natin gawin. I guess we could actually say, right? I guess we could paste some code here. No, start writing function muna. So function naman. So register candidate. Yeah. And then get string code data. Name. Then pwede magiging external. Right, and then on the admin. Right. So wala talaga si school data na lang. School data. Right, so this one right here, so medyo marami siyang consist, no? But yeah, it's basically to allow the registration of a candidate. And then, so itin natin, gusto natin ng function name, register candidate, and it takes a parameter of name, yung name ng candidate, right? So a type of string, right? And then we pass here na call data. So basically, just ignore it for now. So if you use remix IDE, and if it prompts you na kailangan mong in-state kung call data or memory, so we will just use call data for now. And then meron tayong word external here. So basically, siya yung nagka-control kung it's function by external or not, right? Or basically, okay, so we have here candidates, right? So gumawa tayo ng function register candidates, matanggap siya ng name, and we have things. We have a keyword here, name external, so on with external. So meron tayong apat na this access modifiers, right? Or for when you access modifiers in Solidity. Right? So una is external. External is basically start tayo sa public muna. So public is basically, right? So anyone. Basically, sitting in public is like what we've defined here. Kasi ang default kasi public. So public is anyone can or view this variable or function, right? So basically, meron akong parang total global access for this particular function or variable if access modifier is public. Next is external. So what is external? So basically, only functions that are called from outside the contract, right? Contract can use this. So basically, yun nga. So yung mga function na ito yung pwedeng ma-call outside ng contract, right? And next is yung view. So it's view. So view. So it is basically used for functions that only read data. Right? So, ang tala ko ng data. So, yun ang purpose ni view. Okay. So, basically, kumuha ng data or mag-return ng data or to grab some data. Yun ang yung purpose niya to return something, view. And lastly, we have this thing called modifier. Yung tinify natin modifier. Okay. Custom rule. Right, custom rule. That will run before our function. Just like what we defined here. Modifier to, right? So ito yung output na basic na as modifiers in Solidity. So we have public. So anyone can run. External naman kapag yung sa labas only function that are called from us. So ito contact can use this. Which is this, in this case, dinafin natin to as external para magamit natin siya outside. And view as well to that return data as well. And modifier. So siya yung parang for restrictions type of thing. It's basically a custom function, right? Custom rule function as well. So in this case, see register candidates, things external din siya. Tayong set lang yung pwedeng mag-create at the same time in pace registration. So basically, yung pace lang niya is for during registration. So if niran mo tong function na to later and ang current pace is voting or ended, it will basically return an error kasi itong function na to allow lang siya mag-run kapag ang pace is doing registration pace lang, okay? And we only allow na si admin lang yung pwedeng kumuha at same time it's actually external. So the logic for register candidates is basically simple. So basically yung candidates, right? So push natin yung new candidate, right? So gawin natin bagong system candidate, then store name, right? And then we will basically so again, so gumawa tayo ng enroll natin yung register candidate. So basically yung candidates na yun, yung ginawa natin kanina, so gagawa siya ng magpupush siya ng bagong instance ng candidate in which yung name is yung ipapasa natin later na name sa upon creation, right? And then mag-i-emit tayo ng event kasi meron tayong event dito, right? Na candidate registered, so we'll copy that. Emit register candidate and then yung name kasi si candidate registered na doon yung name. Emit ang ipasa natin is name, right? What else? So I will just paste some code here. So we'll paste this logic. So same din function, pero for ano naman siya for voter registration. Ginawa din natin siya external and yung paste din niya is doing ano lang din registration base. So again, kapag kinroll natin itong function na to at ang pace is voting or ended, it will return an error or hindi siya basically ma-allow na mag-run. And then ginawa natin require. So basically itong require na to is para siyang if else conditions, para siyang similar to if those work. So basically may isa siyang condition, right? And require, so basically if yung nag-call ng function na to is registered na siya, okay? So if yung registered property niya, meaning nakapag-register na siya, it will return an error that says already registered. Okay, so we only allow the users na makapag-register isang beses lang. Okay, so if yung condition na to is magto-true, ito yung ma-return. If false to, so magpuproceed tayo dun sa registration. So voters, tapos message the senders, basically yung global object kanina, tapos meron siyang sender. So basically yung sender na to, kung sino yung nag-run ng function, we just later makita natin. And then, registered na siya, right? Yung registered property, set natin to true to indicate na nakapag-register na siya. And then, mag-emit din tayo ng event. So again, hindi to pwede i-run kapag yung user is already registered kasi isang beses lang natin pwedeng allow si user na makapag-register. Alright? So, register na, and since ang in-phase niya is during registration, pag naram siya during voting or ended phase, it will return function. Or basically, hindi siya mag-allow to execute. And then, paste another code here, function name, start voting, right? To start voting. So, similar din dun sa to. So in this register voter, as you can see, di natin siya sinet as only admin because we want the lahat ng users makapag-register. So wala siyang modifier na only admin. So sa start voting, similar to register candidate, we only want na ang makapag-start ng voting is si admin lang. And dapat ang phase is registration. Right, so similar din dito, meron tayong require if ang number ng candidates is greater than 0, right? So, hindi natin i-allow na mag-run tong function na to. And then, basically, instead, return tayo ng error message that says, no candidates registered. Else, if this become false, meaning meron tayong one or more candidates na na-register, then i-change lang natin yung current phase into voting. Right? Which is yung ginawa natin inam kanina. Kasi nag-start ka na ng voting right? Start voting. So we will basically change the current phase into voting. Right? What else? Vote. So we will start. Implement the vote. Right? So vote logic. So I paste it here as well. So vote is similar kay register voter, so external din siya at the same time. Hindi natin nilagay yung only admin because we want all users kasama si admin na maka-vote, right? And then, as you can see here, nag-change na rin tayo ng page. So, we only want this vote na maka-vote yung mga users during voting phase, right? So, ayan. Ilagay natin yung page here. And then, gumawa din tayo ng storage. So basically, storage. Basically yung sender. Right? Yes, tama. So basically, ang ginawa natin is, dun sa voters na, kanina, na mapping. So basically, it stores information, right? So in this case, it stores voters. So, what we did here is basically, igagrab natin sa sender or si voter, right? And then since kukunin natin yung voter na na-store dun sa voters kanina and during voting during voting meron tayong tatlong conditions muna. So if nakapag-register na si voter, right? So, so kung di pa siya parang registered, then di natin siya allow na makaboto. So in this case, kung nakaboto na siya, so hindi natin siya allow na makaboto ulit because we only want the users na makaboto at the same time makapag-register na isang beses. At the same time, if yung gusto niyang iboto is hindi existing, so mag-return tayo dito ng string which says invalid candidate, right? Because that's what we did here as well. And then, if in tatlong conditions na to is turns out to be hindi na-met naman niya na dapat nakapag-register na siya, same time dapat di pa siya nakaboto, and if existing naman yung candidate na gusto niya iboto, therefore set natin yung voted property niya to true to indicate na nakaboto na siya. Tapos yung vote index is basically set natin kung sino yung binoto niya which in this case, yung pinasa natin dito. Right? And then, next is yung candidate. So, i-increment natin yung kandidato na binoto niya based dun sa index na yun, yung candidate index, or basically yung ID ng candidate. Right? And then, mag-i-emit tayo dito ng event, which is podcast, to indicate na nakaboto na si user, na may nangyaring event, or na may nangyaring event that yun nga, nakaboto si user. And then next is, you could also paste this logic as well, and voting, right? So, similar to vote, ginawa din na siya external, pero dito, only admin lang, sa admin lang pwedeng mag-initiate na, mag-end ng voting, right? And then, pwede mo lang natin siyang i-run during voting phase. So, sa logic nila is basically simple lang, no? So, iset natin yung current phase into ended kasi nga, since na-call natin to, tatapusin natin yung voting phase. So, pupunta tayo sa ending phase. And then, dito natin malalaman kung sino yung mga winners, right? So, kuha tayo dito ng variable to get the kung sino yung may pinamataas na boto at the same time kung sino yung kandidato yung nanalo. So, in this case, we use a for loop as well that yun nga, kinagrab yung parang overall logic nung sa boto at the same time. Kapag nakuha na natin dito yung winner, kapag i-emit tayo ng event, then it will basically says there na sa event na yan, yung pangalan ng winner na candidate at the same time kung ilang boto yung nakuha niya for this particular example. Great. So, yun yung logic na yan, voting. So, dito natin makikita kung sino nanalo as well. So, ano pa ba? So, lastly, since meron tayong nasat kanina na view na what do you call this, na access modifier, right? So, we'll use this existing functions that we created just a while ago, get candidates. So, ito yung view. Just like what I said, it's basically view. This function only allows na mag-return ng data or something. In this case, we will return candidates. And kapag tinanggal natin sa return, it will create kasi kailangan niya mag-return, diba? So, yun ang purpose ni candidate, ni view. Right? So, yeah. That's it. So, basically, just for the sake of returning something now. Purpose ni view. Alright, so, I think that's good. What we could do next is, let's start compile again a smart contract. And then, let's start interacting with this particular smart contract. So, click natin yung deploy, ito basically deploy natin siya. So, ito yung, wait lang, before natin siya deploy, let's talk about these accounts. So, imagine this accounts or wallets, okay, as sila yung iba't ibang users na pwede natin gamitin for testing. So, in this case, we will use this first account here as siya yung admin. Bakit? Kasi siya yung magde-deploy or mag-aggregate. And kanina sa constructor natin, kung sino yung nag-deploy, siya yung magiging admin, right? So in this case, this user right here, we're just testing users lang to, by the way. And all this Ethereum stuff here are just testing testing numbers. Wala silang real world value. So if you guys could use this when using Remix, so ano lang sila for testing purposes lang. So ba na gamitin itong C4, then we could click this deploy, and then kapag dineploy natin siya, in this case, pwede natin makapag-interact sa kanya, so may iba't ibang buttons, right? And then yung magiging admin na is yung kung anong account yung selected, which is in this case yung first account, right? So pwede na tayo mag-start may pag-interact this particular smart contract kasi naka-deploy na siya. So example, ito yung smart contract pag naka-deploy na siya sa blockchain, right? So pwede kong gawin, if we okay, open up this terminal right here. So meron tayong nakitang logs. So both are successful, right? So pag click ko yung end voting, magkakaroon tayo ng error. Bakit not allowed in this space? Kasi kaya nasa code natin. Yung end voting is only allow lang siya pag ang base natin is voting. In this case, ang base pa lang kasi natin is registration, right? Okay, so we could start we could start register some candidates. So first of all is, let's say Bob na lang, no, Alice na lang, Alice. So we will register candidate Alice, right? And then kanina, so may register candidate. Si admin lang yung may kakayahan na makapag-register ng candidate, right? And then itong register voter is basically to make this particular account maging voter siya, na maging na-register niya yung sarili niya as a voter. So since click natin kanina yung register voter, magkakaroon ng error. It says already registered kasi nga nakapag-register na to, account na to, right? But sino pa pwede natin i-add as candidate? Pwede si Bob, right? Si Bob. So Bob is also, yun, part na siya ng candidates. And if you click this, get candidates, which is yung view function natin kanina, it will basically return yung candidates na ginawa natin. In this case, si Alice tsaka si Bob, right? Makes sense. So yeah, nakapag-register na rin tayo at the same time. Yun nga, nakapagawa na rin tayo ng candidates. Let's switch on different this account. So in this case, this second account. So we will click this kasi di pa siya nakapag-register as voter. Then, if we click this register candidate, it will return an error kasi nga not authorized. Kasi hindi siya yung admin. Remember, ang admin natin is yung first account. Right. So yun. So register candidate. So we only allow na si admin lang yung makakapag register. Right. Next is, so since nakapag-allow na tayo mag-register, okay, so let's switch on different account naman, just in this case, yung third. So same then, we will set this as to register as a voter, right? Pero pag click natin start voting, since hindi tayo admin, not authorized, kasi nga yung start voting is tayong si admin lang yung pwede mag-start ng voting tsaka mag-end, right? In this case, si admin lang din yung kaya may kakayahan na mag-end ng voting, right? So lastly, switch on this last user. So register voter at the same time. Yan, press na siya. So balik tayo kay admin. So I guess pwede na tayo mag-start voting. Start voting. So you can see here, successful. Pero pag connect ulit natin siya, hindi na pwede kasi ang pace na natin is, since nag-start tayo ng voting, ang pace is magiging voting na, right? So hindi ka na pwedeng i-run to start voting kasi since ang pace is voting, ito is allow lang i-run mag-run doing lang registration phase, right? And then yeah, we can start voting. And since which is error yan, right? As expected. And since sinet natin si admin as pwede rin siyang voter, pwede siyang bumoto for example. So meron tayong tanong pagpipilian. So yung sa vote, diba dito it accepts yung candidate index. So index no all this no candidates. So since ang index ni Alice is 0, tapos si Bob is 0. So let's say we want to vote Alice. So we will pass 0. Kasi yung index ni Alice, diba? So click vote. So successful, right? Successful yung vote kasi may naran na vote cast event dito, and then yung binoto natin is si Alice, right? Pero pag click ulit natin yung vote, it will return an error kasi nga as expected, isang beses lang pwedeng bumoto si user, just like what stated here, already voted, right? So yeah, since nakaboto na si admin, let's switch on other accounts, other users. Let's say sa one account gusto niya iboto is maybe I don't know, si Bob. Si Bob. So type yung index diba, which is 1. So vote, successful. So binoto niya is si Bob. Vote kasi na kanina is this one, right? So if same pa din pag kinip yung vote, it will turn error kasi nakaboto na siya because we only allow users na makaboto ng isang beses lang. Third account, same din. Let's say gusto niya boto si Alice. So yeah, successful. And the last one, maybe switch on this. Let's vote again on Alice. Okay, so same. So di na yung ultimate yan because nakaboto na siya isang beses lang. So since lahat na ng candidates or voters is nakaboto na, pwede na tayo mag-switch sa admin. And then, pwede natin malaman kung ano yung pace. In this case, ang current pace is 1, meaning ang current pace right now is voting. Right? Voting. And since lahat na nakaboto, pwede natin tapusin yung end voting. So since tapos na yung voting, so ayun, election ended, and ang nanalo is si Alice with 3 votes. Right? So yung boto na nakuha niya. So 1 from admin, 1 from this as well. No, from 2 other users, and then yung last is KI, Bob. So si Alice yung nanalo in this election. So get candidates. Ayun pa natin makita dito yung votes. So in this case, si Alice makakuha siya 3 votes. Si Bob is 1 lang. And since tapos na yung voting, hindi na siya pwede end kasi nga tinapasan natin yung overall election, right? So yeah, that's basically a basic introduction about smart contracts. So I hope you learned something about it. And yeah, just to recap, so we talk about structs, mappings, basically store information, talk about modifiers, basically to allow restrictions, right? Like in this, yung only admin. Inalaw lang natin yung si admin lang yung pwedeng makavote or basically gumawa ng isang action. We talk about events, which basically allows this particular contract to interact with decentralized applications or external applications, right? And then we also talk about different control access or access modifiers like yung public, external, view, and modifier. And we also talk about yung contract bases or yung logic flow, which is in this case yung different 3 bases na yun, right? So yeah, that's basically it. Basic introduction about smart contracts. I hope you guys learned something. And yeah. See you until the next one. Thank you.
So that's it, everyone. No, that's Ma'am Dor and now Sir Rommel. So we have a question here from Ella. Sir Federico, are you here? Okay, Sir Federico is not here, but no worries. We'll keep in mind. Oh, yeah, perfect. Sir Shah already answered the questions. Now, thank you all, of course, everyone, for attending this event. And of course, I hope you learned a lot. Now, before we will end our event, I will send a link now for you to get your certificates for a moment. Again, if you want to get your certificates, please answer this form. Is it visible, everyone? Now, again, if you want to get your certificates, kindly answer this form. Now, before we will end, can we open our cameras and take a photo for this event? Unfortunately, my camera is not working, but let's go, guys. It's okay, guys. I understand if you're shy. So wait for a moment. I'll take a screenshot. 1, 2, 3. Okay, again, I already dropped the link of the certificates. Kindly answer the form, and once you answer the form, you will get your certificates. So that's all for today, guys. Thank you so much for attending this event, and I hope you learned a lot from the discussions and the speakers. So that's all, guys. Goodbye. Have a great day.